Welcome to this new tutorial. We will program a shoot 'em up to the evil invaders who came from another galaxy far, far away. With this tutorial, you will learn everything that is necessary to make such a game. If you follow me to the end, you will do the jump into hyperspace of development. You will have in your hands a complete game kit with different types of scrolling, animation, collisions, sounds and procedures. That's why I call this example the Shoot 'em Up Game Kit. The code of this program is of course available in the AOZ Studio's tutorial folder, and the QR code for your smartphone or computer will be presented at the end of the video. Go! As usual, we start quickly, but this time, first I will show you the complete code of this program, and then I will explain it line by line. To begin, let's look at the structure of our program. See at the top left, the program will start by defining some variables. Then we will display the score. Then we will display the scenery that is composed of a layer of desert, this is the effect of global warming, and above, some clouds that will descend at a different speed. Then we will display the player, represented by a small ship at the bottom of the screen, which will move from left to right. Finally, the evil invaders who come from another galaxy far, far, and who will fall on us faster and faster. And finally, the main program loop, which in particular manage the missiles, using two procedures, missile call and missile change. This program has three other less important procedures. Great! This set is the structure of our program, and in particular the main do loop that will rotate permanently managing all our little planet stuff. Let's now look at this in detail. See the pound sign on line 1? This means that following is a command for AOZ Studio, and in this case it is a command not to display its logo at the launch of our program. As you already might know, parts that are written in green are the comments. It is not game code. See line 9 and use of what is called the label. You can create any label you like. It is followed by semicolon, which tells the program that at this place it can be returned to the previous instruction, go to instruction. The program will return to this label when the game is over and will start again. Then we set the values of the variables. Among these variables are values of missiles fired, the time between launches, the number of explosions, etc. Notice that most of these variables are zeroed. Do you think they are useless at their default value? Quite true, but it is a good practice to do so because reading of our program will be facilitated, and I've put the comments to explain what these variables will be used for and to remember later. Also note that some of these variables are marked as global, which means that we will be able to use them everywhere in the game. When I put global in front of NBExplos, it means that this variable will be able to be used everywhere in the program, including in the procedures. Without the global, variables are by default local in procedures. That is, they exist only in the procedure. We are at line 23 now. Stay focused. This is to display the score. For this, I position the print in column 15, line 15, to display the word score, which is put inside quotation marks, followed by the value of the variable score. You see the semicolon? This is for the print statement to order to display the following right after. Let's see the result, with the word score just followed by its value, which is at 0 at this stage, and the small cursor flashing right after. The other symbol in AOZ to learn about is the semicolon. It separates the instructions on a same line. Rather than putting score equals 0 to the next line, I can put it here so that after displaying the score, I start with an empty value, the next game. Then I will ask the program to wait for us to press a key on the keyboard, or a button on the joystick or mouse. And to do all of that, I use the wait input instruction. I also can use wait key for only the touch from the keyboard. Okay, now we will display the background of the game. I create the actor Decor Desert using the desert image. We specify its x equals 0, which is the corner on the far left of the screen. The ship will move on the y-axis, so vertically. We display the top left corner of the image at the 304th pixel on the screen, so at the top, well above the screen, and we will progressively move down the image, which will finish moving when its top left corner will be at 0 at the top of the screen. We then say with the duration parameter that this animation lasts 25,000 milliseconds, and with loop move that the animation loops. Great, we can now do the same vertical animation for the clouds. Its image is, guess what? Clouds! We fix its starting point at X and Y, the end point. This will create a vertical scrolling over the desert. Next, let's go to line 33, Load Asset. It allows us to load what is called a sprite sheet. It's a text file that defines animations. Here we gave it the name Graphics. Note that this file is located in the Resources Assets directory of our application. See the small file there with piles of data that basically defines the player ship, the missiles and the enemies. Graphical animations for us to use. There are graphical tools to create sprite sheets like that. The actor, player, will take care of it at line 36. Notice here in particular left limit and right limit, which fix the screen left and right edges, limiting the movements of an actor. You see, I stop on the left side of the screen and the same on the right. Well, we have just given important characteristics to our actor player, its image, its animations and position limits. Now let's add joystick, keyboard and touchscreen controls. For that, we are using a function called touchscreen that checks if the user pressed a touchscreen. If touchscreen equals true, then we will assign mouse to the parameter control $. So we will use the mouse which is compatible with AOZ's touchscreen. The H only equals true parameter means that only horizontal mouse movements are registered. In cases that there are no inputs, we write else, meaning the player does not use a touchscreen but a joystick or a keyboard. We will define all the parameters, first for the joystick and then for the keyboard. The offsets define the speed at which the actor moves in X or Y. At line 42, see how the animations are defined for the movement to the left of the joystick directly by its name, joy left 0. It may sound weird, but since the early days we were using the name 0 for the first joystick. It would be joy left 1 if there was a second joystick connected, but that doesn't matter. The name of the animation for the left is left 1. This is the name that you will find in the sprite sheet, with the ship that will turn a little bit to the left. We then do the same for the right, then for the keyboard. So we have defined all of this, including the animation when nothing happens, line 47 with the parameter anim equals idle, since the ship moves a little bit when idle. We then apply all these controls. Note that we could have also put all of these parameters one after the other separated by a semicolon rather than line by line in a $C variable. But it's more didactic and easier to read that way, is it not? Okay, so let's stay focused. We managed our scenery, our main ship. Now we will take care of our enemies. There are 3 that have something in common. Despite their different look, they belong to the group enemy, which will allow us to manage them together. You see, at the end of each of their lines, there is a procedure called onChange $ equals enemy change. All good. Let's go back a sec to the structure of our program, the helicopter view. See the parts in yellow, the actors enemy 1, 2 and 3. They call the procedure enemy change. If there is a change concerning the enemies, it is the procedure that will check if the value of y is greater than 304. If y is greater than 304, it means that the enemy is at the bottom, out of the screen, and therefore the player has lost. Then we add a small boom sound that is generated automatically, and then we put the end game variable to 1. I'll go back to the main loop of our program. At line 75, we constantly check if end game is equal 1, and when that is the case, we erase all actors and we restart our program at the start label. Okay, we managed the scenery, the main ship, the enemies, and now we have to manage the missiles that are fired by the player at the enemies. Let's see how I did this in the main loop, do loop of our application. Okay, we'll start at line 64. First, if the user presses a key on the keyboard, or on the gamepad or joystick or mouse button, we create the actor's missile, followed by their ID number, STR $, is an instruction that converts a number into text, thus allowing us to merge it with the text missile. Example, missile 1. All missiles are part of the same actors group, player missile. The missiles will start their movement from the position of the player, the ship, that we set with the actor X and Y functions, and going towards the top automatically thanks to the offset Y. We will also control the missiles with 2 parameters. One is called onCollision $, which, as its name suggests, handles collisions between missiles and enemies with the associated procedure that I called missile call. The other parameter is called onChange $, and calls the procedure missile change. So is everything okay? Shall we continue? We discussed the management of the missiles with the 2 procedures. Missile call that in the event of a collision between a missile and an enemy allows to do a number of things that we will see straight away. Missile changes that will constantly follow the behavior of the missile, especially if the missile comes out at the top of the screen because we will have to destroy it. Missile call manages the collision between a missile and the enemy group. So with any of the three enemies, because all the enemies belong to the same group, if there is a collision, then we erase the missile in that collision thanks to its little name in the variable index1 $. And we display an animation of explosions at this place using the sprite sheet. At the end of line 85, the explosion anim procedure will check that the animation is finished before erasing the missile. It happens automatically, which is very convenient. Imagine the code it would take just to do this. Well, at this point the missile is removed, so in line 87 we now recreate the enemy that was hit by the missile by repositioning it at the very top of the screen. And as the player seems to do well by shooting at the enemies, each time he has destroyed 5 enemies, we will rise the difficulty by increasing the speed by 1 with the inc1 instruction, and we apply this to the actors in the set speed procedure. Let's quickly see the set speed procedure. It simply sets the new speed of movement of enemy ships, which will therefore descend faster and faster whilst the player wins. The value of the offset Y increases. It's Machiavellian. We are back in the missile call procedure that we just left. At line 93, we play a little music that depends on the explosion. Then we increase the score. Why do we increase the score? Because there has just been a collision between a missile and an enemy. So yes, the player has destroyed an enemy, so he wins. It is fair to reward him. We are like that at AOZ Studio. I have not forgotten that it remains for us to see the missile change procedure, which will constantly follow the behavior of the missile. It is the y-axis that interests us. If y is less than 0, that means that our missile is now over the very top of the screen. Well, we can then delete that missile with the actor del statement, because it is not useful to continue displaying it up there. Now let's break our code before I finish. Yes, to understand a little bit better the management of missiles, I will damage our code on purpose in the main loop. See, I removed this part that manages NB missile, so we could not have more than 10 missiles at the same time. You see, the missile no longer goes to the top. It stops because in fact it did not have time to be displayed up at the top, because we are creating too many missiles. So I put this piece of code back in. Similarly, we will look at what is the purpose of this k delay equals k max, and the if, which is just behind. So I delete this part too, and I relaunch my program to see what happens. See, it fires missiles in salvo, because there is no more waiting time between each fire. Have fun editing the code too. Bravo! We have seen the whole of our program code. Let's see it again very quickly as a summary. As I said, summary, meaning at the very beginning, we defined variables, then we displayed a score, then we displayed 2 vertical scrolling actors with the desert and the clouds. We then displayed the actor player, which is the ship. We control it either on a touch screen or with joysticks or keyboards. Then we installed our enemies there. There are 3 different ones that are all part of the same group. And then finally, we increase their speeds with the set speed procedure. And the main loop does not do that much, since it takes care of managing the missiles, and depending on what will happen, it will call what procedure. Missile call handles collisions, and missile change to check where the missile is off screen. That's it. I was a little fast, so it may seem complicated. You may review this video step by step along with the program. It's made to be interactive, but trust me, in a few hours you will be able to make a game using these pieces of the tutorial and show it to the world. Yes, I promised you and your friends will be able to play our game, so let's use the publish feature of AOZ Studio, which allows you to create our program in the AOZ store and generate a web and QR link that you will be able to flash to play your game on smartphone or PC. Congratulations, Magician. Now it's up to you to play, and above all, break the code!